As we left off, chemistry is formally the study of matter. But before we get into, what is matter exactly, we should at least discuss these three states of matter. So, in addition to, again, identifying what this matter is, which we'll get into as well, we want to classify it by its state. And so, its state refers to its physical form. So, that's going to be solid, liquid, or gas. And so based off of those properties. And then, of course, we'll get into composition. And so let's start with state. And so if we look at the distinction, so let's look at our little molecule visual here. So we have solid versus liquid versus gas. And so if we start off, so solid, the particles are tightly packed in place, and we say that they are fixed. Just to be clear, right, this means that even though, right, they're not moving, there is still molecular motion. So I want you guys to be aware of that, right? So your electron's still moving around. There still could be vibrations, wagging. So there's still movement. But we will add some qualifiers here. So usually we say we have a fixed volume. And we also have, right, a fixed shape. So our shape isn't changing, right? I have my solid pen here. Obviously, it's retaining its shape. Same with any sort of, right, these are probably plastic resins ultimately. So they maintain their shape, at least at this temperature. And if we continue, so what separates solid from liquid is essentially energy. And so we've probably seen ice or water at all three states of matter. So we can kind of think about this as well. And so we're thinking about ice here. Okay, it has its fixed shape. And then as we add, again, energy to that, so now things start to change, right? So now the particles are still closely packed together, but now we can say that they can kind of slide past one another. And so, right, they can slide past one another. And so that means that we still have a fixed volume. So y'all are probably aware of that, right? You can have your drink. If you buy it from the store, it says it has a certain amount of milliliters. You pour it into another container, it will still have, right, that same amount of liquid. But we can say now that they have no fixed shape. So they take, obviously, the form of their container. And again, right, you are well aware of that. You can pour water from one container to the next, or another liquid from one container to the next, and it will simply fill that shape. Now let's take that water and we'll imagine kind of boiling it on the stove. And so then we're adding more energy. And as we add more energy, those particles get further and further apart, right? So now they're not just sliding past one another, right? They're really kind of bouncing, moving, jumping out of the container, obviously, as you boil it, until they become gas. And then they're all obviously in the gaseous phase, right? You don't want to do this, but if you forget you are boiling, right, your water, you walk away, all your water is going to be on it, or a majority of it is going to be gone, because it is now in the air as gaseous matter. And so we can add to this, right, no fixed volume or shape. And then we can use a special term here. We can say that gases are compressible. And again, right, you may be aware of this. I always think if you go to Costco, you get your tires filled there. They use nitrogen. And so nitrogen can be compressed all the way down to a liquid. And then you buy it in these, like, or at least Costco does, or any sort of big user of nitrogen labs would do this too. Basically, you purchase a huge dewar of nitrogen, or a tank, it's called, and uh, you can either let it out at a certain pressure. So if you want it liquid, you do it at low pressure. If you want it to come out of gas, it comes out at a higher psi. And all that's to say is, right, Costco has all this liquid nitrogen that is compressed down to a liquid, and then they fill your tires with it. So it is obviously coming out in the gaseous form. And then here's just kind of our text. We can again kind of recap. So solid matter, again, we said they were packed closely in fixed locations. So it mentions, right, we still have vibrational movement. Electrons are still moving around, right? They're not going to slide past one another. And we can think of different examples. So of course, ice, but then we have, aluminum, diamond, any other metals, right? Gold, wood. You can of course find many solid objects. And then in liquid, like we mentioned, again, they're now going to be free to slide past one another. So we mentioned the fixed volume, but not the fixed shape. And so, right, they have this ability to flow. Again, think about different substances. We mentioned water, alcohol. This could be from rubbing alcohol, right? Isopropanol to ethanol or methanol, gasoline. So this is essentially a hydrocarbon, so octane or different octane and hydrocarbon mixtures. But again, you can think of gasoline, any other liquids, right? Gatorade. You've seen liquids. And then, as we mentioned, gaseous, they have a lot of space. So again, meaning we can compress them. They can fill up different volumes of containers. Often, right, we often say that gases will fill the room. And again, just kind of think about that, right? You have a balloon, you pop it. It's not just going to stay in one localized area, right? With that gas, it's going to eventually disperse throughout the entire room, right? As those particles are free to move, again, relative to one another. And then going back to the idea of being compressible. And so this is just a piston system shown here, compressing our gas.